P23. Knowledge, access, power. P23. Wellness and understanding at your fingertips. P23. And that's no cap.
Welcome to this week's episode of Demystifying DNA, Genes and You. What does all of this mean to me, and why is it important? I'm your host, Dr. Tiffany Montgomery, founder and CEO of P23 Health, mom, daughter, sister, friend, and wife to a very amazing husband. Joining me today, we have a new co-host for you all, a gentleman that you've yet to meet on this podcast. However, he also has his own podcast, Hip Hop 50, Mr. Tak Williams. He is a computer expert and wizard. He is highly skilled in people, interpersonal relationships. He is keen on stock and money and investments. He is a mentor. He is a father to 5 amazing girls. He is a brother. He is a friend, and he is an all-around great person to know. He brings a vast amount of wisdom just in life and in learning, and he pops that in with an amazing personality that just stays fresh. We are so honored tonight to have joining us on our podcast, Tak Williams. Welcome, Tak.
Good evening. I want to say thank you, and I appreciate you guys having me on your platform, on your podcast this evening. I was actually turning my head around looking for the guy that you were talking about. I mean, such an amazing intro. I just want to say thank you, and I want all the listeners to know that intro was not sponsored. That was organic. So I just want to say thank you again, Dr. Montgomery. I appreciate you.
Well, you're very welcome. And you can also take this opportunity to correct me if I got anything wrong. So we know the guy. Thank you. And thank you for confirming that you know him as well. Tak is such an amazing person. So thank you for being so humble. This episode uncovers the significance of understanding our genetic makeup and interpreting our DNA. With the surge of direct-to-consumer genetic testing, it's important to comprehend what the data means to you personally and why it matters to your health. Join us as we decipher the language of genes and their impact on our lives. So we're going to have just an everyday conversation with the everyday person, and I'm hoping that you all can relate, you can identify, you can engage, and you can fall in love with this thing called science like I have. So, Tak, I'm going to open it up. I want you to just talk to me. Do you have any questions before we jump into our subject?
I think I wanted to talk about or just mention to you that this idea or the discussion about genes, the genetic makeup, and we as human beings, our understanding of it is one that kind of excites me, while at the same time, I recognize, as grown as I am, how ill-informed I might be. I think at a certain point in my life, I just took what I thought I understood and I just said, okay, I'll go with it from there. But here of late, I've been hearing some really exciting things in terms of what's been brought in by the scientific community as it will, in turn improve healthcare for everybody, address maybe some different diseases from a preventive method, and actually have other use cases when it comes to agriculture, the environment, just humanity as a whole. So that has kind of excited me because I'm in that space of maybe investing, doing some swing trading, and some of these pharmaceutical companies and biomedical companies, they come up a lot. And a lot of times I will not engage or take a position because I really don't have a lot of background in that. And I've just been piecing it together. That's why I was excited to actually come on your platform, because I said, okay, this will give me will reset my foundation or basis of understanding. It will probably wipe out a lot of my stereotypes or generalities that I've been carrying, and it'll get me more informed. Therefore, I can make a better decision when it comes to, positioning my money or trying to generate wealth from those opportunities. Not to say that, put aside the importance of this, but I'm just letting you know what caught my excitement about it, and especially being on your show this evening.
Hey, that's excellent to share. And whatever brought you here, trust me, I'm happy to have you because I love to talk about science and I love for people to relate, right? And understand that importance and why it matters. I always say this, I find myself saying it, I don't want to sound old, but when I was younger, or like the older people say back in my day, I would find the importance of math. And you would always hear your parents talk about math and your teachers talk about math. And they would say math is a field that translates into every area of your life, right? Whatever it is that you want to do, you're going to have to understand math. Now, as we are evolving as a culture, as a society, as we come into this new age of awareness or wokeness or truth, we are finding that science is just as important. Genetics are the building blocks of who we are. It's how traits, characteristics, and information is passed down from one generation to the next. So it's crucial. Genetics is one of the things that have remained true, right? Sometimes we can change a family story. We can go 3 or 4 generations, and granddaddy, who was a farmer, now becomes the first attorney in the family, right? You can kind of put your spin on what is your version of the truth, but genetics has no perception. It is something that has remained unmanipulated for centuries. We'll talk about it a little bit later because now we are entering an age where manipulation is happening. But up until 2020, it was something that was maintained. It was held dear. That genetics is crucial to understanding inheritance of traits because they're like instruction codes for our body and they're passed down from your parents and their parents. They determine our physical and behavioral traits, our eye color, our height, even whether we're good at certain things. Genetics is helping us understand diseases because it plays such a significant role in preventing diseases. Some health conditions are caused or influenced by our genes. Our susceptibility to infectious disease is determined by our genes. By studying genetics, scientists can learn the cause of the diseases and develop ways to prevent or treat them. As we delve into genetics, it's becoming more important and leading innovation in medical research and treatment. Genetics have become essential in medical research, and scientists are using the genetic information to develop new treatments and medication, personalized medicine, where treatments are tailored to an individual's genetic makeup, and that is becoming more common and effective. Evolutionary studies, where we look at how a species is evolving over time and look at that relationship between different organisms to see how they've adapted or evolved. Agriculture. In agriculture, genetics is used to improve crops and livestock. Scientists can select a breed of plants or animals and even give them desirable traits, such as resistance to disease or better productivity, improving food production. We call it GMO, genetically modified or genetically modified optimizations to our foods. Forensic science. Genetics is crucial in forensic science for solving crimes. DNA analysis can be used to identify individuals, establish relationships like paternity or even sibling relationships, provide important evidence in criminal investigations, and even help with discovering or tracing like your ancestry, right? Reproductive health. Genetics is important to reproductive health, and understanding genetic factors help us in diagnosing and addressing fertility issues, preventing genetic disorders in newborns, and providing genetic counseling to prospective parents. Is also in the field of genetics becoming important to help us with conservation, where in conservation, we are trying to conserve endangered species. So in this instance, genetics is used to assess genetic diversity and develop strategies to ensure the survival of these species. Genetics is important because it helps us understand the fundamental building blocks of life, how traits are inherited, and how this information can be applied to various fields, such as medicine, agriculture, conservation, and money, stock market, everything. When you're understanding where we're going and the tools that we're using to get there, it makes a whole new world or gives you a whole new perspective of how to analyze and assess things.
So, Dr. Montgomery, with genes, just for the person listening in, yeah, they might be an adult, because I think the younger generations, if they want to be more in tune, they probably are because of the resources and everything that's available to them. But for a person that's been around for 40 to 70 years, 40 to 80 years, what was explained to them in terms of genetic makeups, the breakdown of the code, as they used to say, that little strange looking helix form or whatever that is? What has changed? What is like some of the significant differences in terms of research, what has been brought to light and proven and studied upon, that gives us a different sense of what we may have been taught about genes then and now, if you go back a couple generations?
So we didn't know why, right? We didn't have quite a name for it. But the thought of origin and this conservation and understanding things being passed down from generation to generation got on our scientific radar in the 1800s, late 1800s, around 1859, right? And then in the 1900s, there was a push for the eugenics movement. And that kind of led us down the road or the pathway with Mendel to start thinking about how Darwin's theories really translated, how we could prove them. How does evolution work? What can we do to establish those relationships? Then in about 1944, Oswald Avery identified DNA as a transforming principle. And it wasn't until 44 that DNA was identified as such. We fast forward, and I'm explaining this because when you're talking about somebody 80 years old, you're talking about 1940s, okay? We have a lot of people, because people are living longer, who have watched this whole process of DNA from where we are now to where they started go and really grow over the past 80 years. In 1952, Rosalind Franklin was the first scientist, London born, who was able to actually photograph the crystallized DNA fibers. She used beautiful x-rays. Now, she did not know that those x-rays were carcinogenic or that they would cause cancer. And ultimately, she did so many x-rays, she did develop cancer and she did pass. But her name lives on. In 1953, Watson and Crick picked up and were cloned the fathers of discovering this double helix structure, but it was for the work and the sacrifice of Rosalind Franklin. We moved forward from 53, which was very, very exciting, all the way to 77, where Sanger developed sequencing this DNA. Then in 1983, Huntington's disease is mapped. And we start thinking about, as a scientific community, how this can translate to other diseases, how we can really delve into this thing called DNA. So in 1990, the Human Genome Project begins, and we began sequencing viruses, bacteria. It was like the birth of DNA. It was a time of awakening and excitement Then in 1996, using all of these principles, Dolly, a sheep, is cloned. It was the first known cloning. It was as big as AI is for us now, right? Everybody's talking about AI, but I remember when people didn't even have cell phones, and now you have a cell phone that can talk, that can help you with appointments, that is really a very strong form of artificial intelligence. And who knows over the next, 40 years where that's going to go. The same principles apply, or the same awe comes with technology as we look at where we are with DNA. Fast forwarding to 1999, the first human chromosome was decoded. As we move forward, 2003, that Human Genome Project was completed. And once this happens, we began to really further the breakthroughs in science. By 2014, we had already started with looking at different organisms, looking at expanding artificial genetic code, looking at translating these things from the research environment into the clinical lab, where we could detect viruses, fungi, bacteria, microorganisms in general, infectious disease, by using these molecular methods or these DNA, RNA based methods for detection. So if you look at a person who's in their 40th to 80th year of life, you're looking at somebody who's lived that entire journey of furthering science and looking at each decade. Us as a civilization push the envelope further and further. We constantly challenge what we can do, what we can ask DNA, and what it means. Now we're at the point where we're looking at different SNPs or segments of a gene, and we're able to identify certain mutations on chromosomes, certain things that make us prone to genetic diseases. And I hate to say it, Talk, but this is only the beginning. It's so much that we don't know the code for yet. We don't know how that interaction is with another gene. We don't understand yet, other than just saying it's environmental, what are the specific epigenetic factors that will turn something on or off. My guess is in the next 10 or 15 years, we're going to start answering even those questions.
Hence, I want to go right into CRISPR, Cas9. The FDA, late or early part of December 2023, actually approved clinical trials for the company CRISPR or am I pronouncing it right? Cas9. And basically the U.S.
It's not a company, it's a technology.
It's a technology? Okay. So the U.S. Food and Drug Administration approved 2 milestone treatments by this company. And basically, they're able to do what, in layman terms, is called genetic editing. And I mean, they're even using terms like cut and paste and snip like scissors and like some real live, easy to understand concepts. They're using terms like this is a tool. And the idea of that language being used, how it's being presented, how it's being communicated, does so much for like people like me and others in society. Because a lot of times we don't even understand, should we even get excited about technologies and just things on the frontiers of health and genetics and whatever that is, because we're disconnected from the language. We don't understand what's being said. But as it was presented, whether it be in TED Talks, on CNBC, where I caught it at, and other venues and platforms, they're saying that CRISPR-Cas9 is a tool that can be used to actually go in and with the combination of the DNA, the RNA, whatever it is, it snips it out, it matches the code, and then it can do translation and other things and actually rid the cell of that genetic deformity. And I was actually looking at a CNN report based on some of the information you had sent me, and they was talking about this young man. He's not even 18. I think he's 13 or 12 or something like that. His parents allowed him to participate in one of the trials because he suffered so much from sickle cell. Now, as an African American and part Japanese, we have to be very clear that in this country of the United States, African Americans are predominantly the people or the race that suffer from sickle cell. No cure for it at this point. This young man participated in that group, that trial, and he has not had a sickle cell crisis, as they refer to it, in almost 2 years. In fact, they said out of the 30 people that participated in the trial, 28 of them have not had a recurrence of any sickle cell related crisis for maybe up to 18 months or so. So this is like right out front. People know what sickle cell is, the language being used in our face, and that's why I'm saying I think that this is wonderful. So when you talk about, there's the coding and there's things to come and there's so much potential here, I get it, because their emphasis is on genetic deformities. What is it? Huntington's disease. Like what is that? Muscular dystrophy. What is that? Sickle cell. What is that? Cystic fibrosis, right? And we can go on. There's like the 5 usual suspects, right? And you can name these, and they say, oh, well, it's in the gene, and they can inform you, but there's not much to be done. So the idea that CRISPR, which I don't even want to get into what it stands for because we know it's a acronym for something, it actually goes in, locates it, identifies it, and snips it out between the DNA and the RNA. I think that is just crazy cool.
So you unpacked a lot. I think you were the scientist, and I felt like I was a student for a second there. It's a lot to take in on the news. You summed it up very well. I'm going to go back over a couple of points, not because you didn't do an excellent job, but just because I want to get our readers up to speed. Maybe they missed the FDA announcement, right, about the first gene therapy to be approved. So we're going to kind of talk about this a little bit. CRISPR-Cas9 stands for clustered, regularly interspaced, short palindromic repeats, and CRISPR-associated protein 9. All right. Let's break down what each part of that means. So our clustered, regularly interspaced, short palindromic repeats are specific DNA sequences found in the genomes of bacteria and other microorganisms. They contain short, partially palindromic repeated sequences that are interspaced with unique DNA sequences. CRISPR was initially discovered as a part of the bacterial immune system, where it helps bacteria defend against evading viruses by storing a memory of the virus's genetic code. Cas9, or CRISPR-associated protein 9, is an enzyme that plays a crucial role in the CRISPR gene editing system. It acts like a pair of molecular scissors capable of cutting DNA at specific locations. By guiding Cas9 to a precise spot on the DNA using a molecule called RNA, which is designed to match that targeted DNA sequence, scientists can make precise changes to the genetic code. In simpler terms, CRISPR-Cas9 is a revolutionary gene editing technology that allows scientists to modify and edit genes in a precise, targeted manner. It has enormous potential for various applications, from treating genetic disorders to creating genetically modified organisms for agricultural research purposes. Now, Dr. Montgomery said a lot of words, and I want to just understand this. So I'm going to back it up. And I want you to imagine again that your body is like a big instruction book. And this book tells your cells how to build and how to grow. We all know if we've ever written a paper or anything, you can make a mistake, right? So in this book, sometimes there are typos or mistakes that can cause problems. Gene editing is like using a special tool, we talked about the scissors, to fix those mistakes in the instructions. You could think about it as scissors, as whiteout, anything that you would use to fix a mistake when you're typing. Now, where we are, our scientific community has found a way to go inside these tiny building blocks of life called genes and make changes to them. It's like fixing a sentence in a storybook to make sure it makes sense. This helps make sure our bodies work the way they should and can even prevent some illnesses. In the cases of sickle cell, we are now trying to see if it can eliminate illnesses even after that gene has been activated or turned on. Just like a superhero with a superpower to fix things, gene editing is like a super tool for fixing these mistakes in our instructions so our bodies can be healthier. As a scientific community, I have to be honest, we're still learning a lot about it. But it's super exciting and it's an important adventure in the world of science. Now, with that said, the first FDA-approved treatment has been released for the treatment of sickle cell, which, as you mentioned, is a predominantly Black disease. It affects predominantly melanated people of color, not just in the U.S., worldwide, especially prevalent in Africa, where the only protective factor for it is malaria. With that said, I know you mentioned that you were part African American, part Japanese. I am all part foundational Black American from the United States. My ancestors came over and were slaves in Mississippi and Arkansas. I understand the effects of sickle cell. In fact, I am a graduate of Tuskegee University, and I'm not sure if you are familiar, but there was a Tuskegee syphilis experiment that took place there.
Absolutely, I am familiar with it.
In 2003 or 4, President Bill Clinton did an apology for the syphilis experiment at Tuskegee and founded the first center of bioethics in Tuskegee, Alabama. Coming from that community, being a part of that community, working part of I led the Scientific Honor Society, and every year the president got to pick the community service project that we did. I don't have sickle cell myself, but I chose for us to volunteer with the Southeast Alabama Sickle Cell Association. It was at a time where the state was doing very bad, budgets was cut, and that was one of the first budgets that were cut. So I feel very dear, not only to the Black community, not only to sickle cell, but to my commitment to bioethics and responsible research, informed consent, and helping people be health literate enough to understand what is happening to them and why, what they're agreeing to, what are they consenting to. I think that gene editing is phenomenal in its potential impact. It's a process of altering and modifying specific genes. It can be used to enhance desirable traits or remove undesirable traits, remove undesirable diseases. It's a technology such as CRISPR-Cas9 that has and will continue to revolutionize the field of biotechnology, opening up new possibilities for medicine, agriculture, bioengineering. However, gene editing is going to raise some ethical, social, legal, and safety issues. It has to be regulated and practiced responsibly. And it's got morality ties to it because you're modifying living beings. As I stated earlier, we don't understand the full code yet. So just because we're making a change, does that change impact anything else or what else? Because science has taught us and we've accepted the law that for every action, there's an equal and opposite reaction. So for me, while I'm excited about it, my moral compass and my ethics has questions. I have doubts. I have concerns. And I have to be true and honest when I say my first question is, why would the first approved CRISPR technology be for sickle cell disease? Why?
Yeah, I understand that. I think that is a question that should get a lot of response and concern and focus, that should be thought through communities, whether it be the medical community, the legal community, throughout. I think that conversations have already taken place that this might be the sequel to other studies, such as the Tuskegee study that was conducted and imposed on African Americans, Black people in this country, and how deliberate and intentional that was. And, we can just go on from there. So I definitely hear you and respect that position or that insight, because that's worthy and it commands that thought. There's nothing out there about that. There's nothing extreme about it. Anyone who's read anything or paid attention to, the body of work that this country has in healthcare, in science, and who they decide to run these experiments on would find that a very reasonable question for many to answer, and it should be answered. I do want to mention that with anything, there is the good, the bad, and sometimes the ugly. And so I can appreciate you mentioning about the excitement or maybe the pause or lack thereof to some extent. The good of this with CRISPR as a tool is things like treatment of genetic diseases, cancer research and therapy, HIV, AIDS treatment, different things like that. Prevention of infectious diseases. But I would like to mention a name that speaks to maybe not the good, but possibly the bad and the ugly, which ties directly in with the ethics that you brought up. And that would be Ha-Shah-Kui. Now, Ha-Shah-Kui was a biochemist. He wasn't a geneticist. That he wasn't. He wasn't that core group of people who worked on and developed the CRISPR-Cas9. He didn't hold that title. He didn't look like them on paper. He was a biochemist. And he, in 2018, worked secretly and basically edited the gene structures of two Chinese or a set of Chinese twins. And then he came out and told everybody. Now, while he was working on that project secretly, moving around throughout the medical and the health field and the science field, and he was picking people and toying with the idea, and the whole time he was already working on it. And then the twins were born healthy. He says he did it because their father was HIV positive. And what he identified using CRISPR-Cas9 was there's a gene or part of the gene called CCR5, however it's labeled, right? And that has directly or has something to do directly with how HIV affects us. So he basically said, hey, there's no cure for HIV. This is 2018. There's no cure for it, but I can edit the genes with the CRISPR-Cas9 and make it resistant to the HIV. And he did that, put it back into the mother, and she had the twins, and they're healthy. They didn't, take on anything that looked like they've been affected by the HIV that their dad has. Now, this is China, right? So how they can get down a little different every now and then. In 2019, they sent them to jail for 3 years because it became an ethics. It comes out now that this CRISPR-Cas9 system is built and structured such that you don't have to be a geneticist. You don't even have to have that level of acumen and talent. You can be somebody that knows enough. In fact, they sell CRISPR-Cas kits on Amazon. Now, you can't work with the human genome through that, but some plants and other things, you can just buy it off of Amazon. So I definitely hear you. And I think that's something that's in the arena, in the basically that domain that's being talked about now. Where does the ethics lie? How do we measure, or how do we decide, or who even decides where the good, the bad, and potentially the ugly lies? That's a great point. That's just something that we have to.
I think that you hit the nail on the head and summed it up very nicely. There are going to be 1,000 reasons that we ask why. Having that knowledge helps you answer that question. It's not only important to ask why, but why not? Having open discussions like this increases our understanding. Breaking science down in a way that we can really become involved in those discussions and share our thoughts, not from an emotional manner, but from a calm, well-rounded, what is the impact? I hope this podcast challenges you to think critically, to go above and beyond even what you ever thought you were capable of. Having this conversation with Talk has reminded me of my very first day at Tuskegee University. One of my very favorite professors, Professor Emeritus, was a student of Dr. George Washington Carver. He was an older man, maybe about 90, in his 90s. We won't put an additional number. And he walked into freshman biology class just as meek and calm as you can imagine. Slow, very well collected, stack of books. And the very first words he said to us are going to be the words that I leave you with. This is also the first thing that I taught my children. It is a poem. The poem is titled Equipment by Edgar A. Guest. Figure it out for yourself, my lad. You've all the greatest of men have had. 2 arms, 2 hands, 2 legs, 2 eyes, and a brain to use if you would be wise. With this equipment, they all began. So start from the top and say, I can. Look them over, the wise and the great. They take their food from a common plate, and similar knives and forks they use. With similar laces, they tie their shoes. The world considers them brave and smart, but you have all they had when they made their start. You can triumph and come to skill. You can be great if only you will. You're well equipped for the fight you choose. You have legs and arms and a brain to use. And the man who has risen great deeds to do began his life with no more than you. You are the handicap you must face. You are the one who must choose your place. You must say where you want to go, how much you will study the truth to know. God has equipped you for life, but he lets you decide what you want to be. Courage must come from the soul within. The man must furnish the will to win. So figure it out for yourself, my lad. You were born with all that the great have had. With your equipment, they all began. Get a hold of yourself and say, I can. We've reached the end of another engaging episode of Demystifying DNA. A big thank you for accompanying us on this exploration of genetics and its relevance to us. At P23 Health, we believe in the importance of understanding your genes for better health outcomes. We're committed to providing you with direct-to-consumer genetic tests that offer meaningful and actionable insights. Our aim is to empower you with the knowledge you need to make informed health decisions right from the comfort of your home. It's crucial to remember that the knowledge about your genes is the first step towards taking control of your health. We encourage you to stay inquisitive and vigilant about your health journey. To learn more about how P23 Health can assist you, please visit our website at p23health.com for comprehensive information on our testing options. Thank you once again for tuning in. I'm your host, scientist, epidemiologist, and just that curious lady, Dr. Tiffany Montgomery, along with my co-host today, Talk Williams, saying goodbye from Demystifying DNA. Continue exploring, stay informed, and take charge of your health journey one gene at a time. And remember, we are with you every step of the way. Until next time, be well.
P23. Knowledge, access, power. P23. Wellness and understanding at your fingertips. P23. And that's no cap.